Hi everybody, today we're going to balance two chemical equations. As it indicates in the directions, we want to make an accounting table and then we want to pick coefficients to balance the number and type on the reactant and product side so that we can satisfy the law of conservation of mass. My suggestion is that you take a minute to try to do that and then click play and see what I do. Alright, so making the accounting table here, I've got carbon, hydrogen, and oxygen. Remember, I list them in order that I read them. We're going to have to do some addition because we've got hydrogens here, and we've got oxygens here and here, but we only give hydrogen one line in the accounting table. Likewise, we only give oxygen one line in the accounting table. Whatever order I make the accounting table in on the left-hand side, I make it in exactly the same order on the right-hand side so that my eye can easily scan back and forth to see if I'm balanced. Now I'm going to take account for the initial number and type that I have on the reactant and the product side. I have 6 carbons. I have 5 plus 1 is 6 hydrogens. I also have 1 plus 2 is 3 oxygens. On the product side, I have 1 carbon, 2 hydrogens, and 2 plus 1 is 3 oxygens. Okay, so I can see that quite a few things are unbalanced. Remember the general principle of combustion reactions. This is a combustion reaction because it has a hydrocarbon plus diatomic oxygen, makes carbon dioxide and water. With combustion reactions, you always have to save oxygen for last. So it doesn't matter if we balance the carbon or hydrogen first, but we have to save oxygen for last. So I can see that I've got 6 carbons on the left and 1 on the right, so I need to work on the right-hand side, and I need to pick a coefficient of 6. That 6 distributes and multiplies to change both the number of carbons and oxygens. So I now have 6 carbons, and I have 6 times 2 is 12 oxygens plus 1, 13 oxygens on the right. Now to balance hydrogen, 6 versus 2, I can see that I need a coefficient 3 right there. That will give me 6 hydrogens. And for oxygens, I've got these 12 plus these 3, that's 15. Now, to balance the oxygens, we could use a guess and check method, but I like to be a little bit more strategic about it. If you take a look, we don't want to put a coefficient over here to balance oxygen, because that would unbalance the carbons and the hydrogens. So what I'm going to say is, what's 15 minus 1? That's 14. What's 14 divided by 2, that's 7. I can double check that. 7 times 2 is 14 plus 1. That gives me 15 oxygens. So this one is now balanced. By the way, again, this is a combustion reaction, and we always have to save oxygen for last in combustion reactions. Okay, number 2 right here, we could classify this as a double replacement reaction. Or you might know about acid-base reactions. This is also a special type of double replacement called an acid-base reaction. Taking account for the number and type that I've got on the left and right and making the accounting table is going to look like this. Aluminum. Hydroxide, OH, is broken up on the right-hand side, so for that reason I need to have an oxygen line and a hydrogen line. Oxygen and hydrogen. Sulfate, however, is not broken up on the left and the right. Sulfate is unchanged, so I might as well save some work for myself and make a sulfate line. So I've got aluminum, oxygen, hydrogen, sulfate would have a -2 charge. Taking account for what I have, it's 1 aluminum. It's 3 oxygens that are right here. It's these 3 hydrogens plus these 2. That gives me a total of 5 hydrogens. 1 single sulfate. Product side, 2 aluminums, 3 sulfates, 2 hydrogens, 1 oxygen. Okay, I want to leave the oxygen and the hydrogen alone because see how many things are mismatched, and we also have these even-odd combinations which are difficult to deal with. So I'm going to choose to work with aluminum first. And I need to work with it on the reactant side because I have more on the product side. So I need a coefficient 2 right there. I'm going to draw my swirly distribution arrows just to show that there's a lot of accounting that we have to do right here. It also modifies the number of oxygens. So now I've got 2 times 3 is going to be 6 oxygens, and I've got 2 times 3 is going to be 6 hydrogens, plus these 2 over here. That gives me 8 hydrogens currently. Now I move on to the sulfate. I've got 3 on the product side, but 1 on the reactant side. So I always work on the side that has a fewer number of that particular substance. So I need a coefficient 3 right here. That's going to give me 3 sulfates, and then I need to redo the accounting for hydrogen. So I've got these 6 hydrogens plus 2 times 3 is 6, so 6 plus 6, that gives me 12 hydrogens. Now if you take a look, it's nice because we've got a 2-to-1 ratio of hydrogen into oxygen over here because we have water. We've also got a 2-to-1 ratio over here. So for that reason, my last coefficient is a 6 right there. That's going to give me 12 hydrogens, 6 oxygens, and because we've been nice and neat and organized with our accounting table, our eye can easily scan left to right and see that we're balanced out. So again, that's balanced. You could call this a double replacement reaction, but you could also call it an acid-base reaction as well. All right, thanks a lot, guys. Have a great day.